Okay, we're going to look at the last question. The last question, a probability question. It's about combinations and arrangements. And here we go. A teacher has five different poetry books, four different drama, and three different novels. She's got to arrange these 12 books from left to right on a shelf. Write down the probability that a novel will be the first book placed on the shelf. Well, there's 12 books to choose from, and three of them are novels. So three chances in 12. Ooh, that's a nice, easy point. One chance in four. That's it. Calculate the number of different ways you can put 12 books on the shelf. 12 books in 12 places. Well, you just have to know you got 12 choices, then 11, all the way down to one choice at the end. It's 12 factorial. Or you can use that lovely 12 choose 12 button for permutations and combinations on your calculator, and you get the same answer, which is a giant one. It looks like 479,001,600. Okay. Now, the last question's a little tricky, but I'm going to go through it. Um, First, just sort of talking about the different possibilities, but how I do it, I like the way it's laid out in the memo. I did a little bit differently, but anyways, calculate the probability that a poetry book is placed in the first position, that the three novels are all placed together, and that a drama book is placed in the last position. Okay. Well, let's think about this. Now, when they say the novels have to go together, uh, there's 12 books, so I put 12 boxes. This is the way I like to do it, 12 boxes. Now, the three books, novels, have to be together. So I kind of tie a rope around them and put three boxes. They've just turned into like one choice, like they're like one box now, except there's three different ways they can be arranged. Now, let's just go through it. So you've got on the very first one, there's five poetry books. So that's five choices right there. At the end, you've got to put a drama book. There's four choices there. Okay. Now, so that's five for poetry, four for drama. Now we're doing a probability over the total number of arrangements. So the total number of possibilities is 12 factorial. So I think in the memo, one mark might be just for putting 12 factorial in the bottom. Five poetry choices in the first, so it's times five. Four drama choices, so it's times four. That's worth some marks. Now you're going to put the three novels together, but there's three times two times one, three factorial ways to arrange them. So there's 5 times 3 factorial times 4. How did we come up with 8 factorial here, though? Well, I'll tell you, this is how I did it. I figure if I choose a poetry book, I've got four other choices where the books can go. If I choose a drama at the end, I've got three more. Okay. The three and have to go together as one choice. Well, 4 plus 3 plus 1, there's just eight other ways to arrange the books. See, four choices, three. Once you choose a poetry, the other four, in the first, there's four other poetry choices you can make. Once you choose a drama, there's three more. And the three novels together are one. That's 8 factorial. That's the arrangements of the rest of the books. Well, there it all is. Five poetry in the first, four drama at the end, eight other books, and three different ways to put the novels together. That goes on the top. That's your chosen outcomes that they describe, divided by 12 factorial, all the ways the books can be arranged. And there you have it. My calculator told me there's one chance in 99. And that's it. That's the answer.